Last week, we talked about, that we need objects to do physics. And so we need to put physics in the proper context. Okay, and here it is. Okay, this was what I put out there. Science equals rational explanations. That's what science is. Science is not descriptions, like in mathematical physics. They describe something mathematically and they call it a theory. No, a theory is an explanation, not a description. And an explanation is not a bunch of descriptions either. You need to have causes, and descriptions don't give you causes. Physics, we don't do philosophy here, but there's the definition, the way we look at it. Rational explanations of reasons and purposes. It's about behavior, why people do stuff. We don't do that, that's for psychology, historians, etc. Major people who major in those subjects. We do physics, and physics is rational explanations of causes and mechanisms. Okay, so that's our starting point. And so now we know what physics is according to this site. You don't have to agree. A couple of people don't agree, and they say, when you say we, do you say we, do you mean Bill and Hans? That's my son, my younger son. I don't recall anyone else doing physics your way. Okay? Another fellow says, you're barking at the wrong tree. You need to stop focusing on what physics should be. It is what it is, always been math. You would like physics to explain, but that's not what it does, right? Physicists don't care about the why. And they're not physicists, they're mathematicians who call themselves physicists. You're going to need to come up with your own science, answer the why. Call it bgaedes. Yeah, the issue here is, we don't care how many people in the world vote for a definition. Definition is something you defend, not something you vote for, not something you look up in the dictionary, not something that you do because of tradition or because, authority, that's what they taught you, or that's what you learned, etc. None of that has anything to do with science. In science, you have to defend your definition. You have to get your shield, your sword, and fight. Get in that ring and fight. And all I can tell you is people say, explanations, physical interpretations are not part of science. That's what they say. Well, people then ask, why does this pencil fall to the floor? Why does it fall downward? Why does it fall to the ceiling? And no one in the last 10,000 years can answer that question. And that's the type of question people ask, because people don't, the common man, the layman, they don't care about math, equations, calculus. They're far away from that. They say, well, why does a spoon fall to the floor? Please explain. These people cannot explain. They say space-time is warped. What do you mean space-time is warped? Space-time is a concept. Yeah, we don't understand it either, and that's philosophy anyways. So two things. Why did they try to answer that question? Why did we go to the physicists, so-called physicists, to try to get an answer to that question if that's not part of physics? Second, who does? Who should I go to, if not a physicist, to tell me why the pen falls to the floor, if not a physicist? Who handles that subject matter, if not a physicist? And these people will tell you that they don't do that kind of work, but then they do try to do it. They try to give you an explanation. Why? I mean, don't give me an explanation. Just stick to your math, your equations, and we're done, right? Why are they trying to give you a physical interpretation? And so those are the questions you have to ask yourself. And then you do have people like I showed James Beecham, and he says, that physicists want to know why. They do want to know why, just like anybody else, but they don't know why, and so they give you these irrational explanations that space-time is warped. So, it's up to you to figure out, and every man's up for himself. You can't just go out there and say, well, this is what all the physicists say, or what the mathematicians say. We don't care if all of them gang together and form the Flat Earth Society. Does that make it real? So every man's for himself. You got to reach your own conclusion by yourself. Okay, so what did we say? Here we have it. Foundations of physics, right? This is what's the base of this discipline, okay? Golden principle of physics. You can't do physics without an object. You need an object. If we have no things in the universe, no object, no atoms, no gases, no planets, no nothing, right? What's happening? What's taking place? What physics is happening? What would there be to explain? What experiments would you run, assuming the experiments are part of the scientific method, right? I mean, what's happening if there's nothing there? So the first thing you need is objects. You need to put objects in there. And so the first definition we need in physics is the word object. You need to know what an object is. An object, that which has shape. There you have a shape, black one. I hope you see it. It's got shape. We don't know what it is, but that's an object. Call it X if you want. Okay, no problem whatsoever. Okay, so we know what an object is that which has shape. Okay. Now, a fellow said the other day, made me laugh, says, no 3D object has shape. No 3D object has shape. It has form. Well, I told them that in other languages, there's no word for shape. I know at least 2 languages that don't have it. One is Spanish, the other one is German. They don't have a word for shape. It's always form. Everybody uses form in those countries. So there is no word for shape. Shape, everybody identifies with 2D and form with 3D. In physics, we call it shape or form are synonyms. But even if we were to go with this fellow's objection, every object, 3D, right? Every 3D object has shape because shape is a 2D property by definition or according to the way they see it. And every 3D object includes 2D surface, face, or whatever. So all forms include shapes. And by using the word shape, we cover all objects in the universe, whether they're 2D or 3D. So shape is the correct word, okay, in English, right? In other languages, we use the word form. Okay, anyways, fellow says that action forms objects. He says that objects are made of motion. And that's one of the things we're going to look at today. No, it ain't. First, you have to have an object before you have motion. You have to define the word object before you define the word motion, action, or change of position, or whatever you want to call it. You need objects to do motion. And they want to do it in reverse. They say motion builds objects. Objects are built of motion. No, absolutely not. But this is what they have in the back of their minds. And so he says an object is an obstruction that was thrown in your way. An object would mean an entity which is thrown in the way of another. In other words, see touch, primarily touch he's referring to here. You need touch. And no, because now you have 2 entities. You need 2 entities to define object and entity. So it's an irrational notion what this fellow proposes. He can't defend that under any circumstances. The see-touch criteria are both irrational, both see and touch, because you need a second object to do the seeing or the touching. And you need an experiment. You need the experiment of seeing and touching. Is the asteroid an object before it touches the moon? Hopefully before any entity touches or sees something else, it's already an entity. And so you need to define entity before the see and touch, before they do see and touch. So because of this fellow's definition, he ends up with nonsense like, that water and air are not things, okay? Motion is a property of matter. It needs motion to maintain form. Absolutely not. Form is a static concept. We see it in a single frame. We don't need to see motion in order to have form. Okay? We're not talking about forming something. We're saying that whatever has form, whatever has shape, static concept, we see it in a single picture. And there you see it. He comes up with the notion that water doesn't have shape. And that's why, because they have this notion in the back of their minds that water is malleable. It changes shape from second to second, from frame to frame. Yeah, changes. So does gas, right? So we have all these, objects. You have like table. Table doesn't change its shape immediately, even though every atom in there is moving. But he didn't realize that. Every atom of your table is moving. The electrons are moving. Everything's vibrating in there. We don't see it every day, but your table is moving, okay? It doesn't move like from here to the other side of the room, but every atom in there is moving. So you're not touching a static thing when you touch a table. It's already in motion. All the atoms are moving, vibrating in there. They're doing their jiggle, right? But irrespective of that, the question here is the following. If we take a snapshot of the table, if we take a snapshot of water, if we take a snapshot of air, if it's color-coded, you take a snapshot, you would see a blob. You would see a shape, a form there in front of your eyes. And there you see it. Here you have the astronaut. Pops the balloon. You had a red balloon there. And it's water. Air, you want air? No problem. Air or water wouldn't matter. You have a blob of atoms coming out. You take a snapshot at a given point, and there it is. There's your snapshot of water, right? And does that thing have shape? And it's not a question of what is the shape of. No, the question is a yes or no type of question. Does it have shape? The answer there hopefully is yes. Water does have shape, so he is absolutely wrong that water doesn't have shape. Yeah, water has shape and doesn't need a container, because this one is down in outer space without a container. So yeah, you can put water in a balloon, you can put water in a container, and it has the shape of a container, right? But you can have water complete or air out there in the middle of space, and it'll be a blob, which gradually disperses probably. We don't care. We just say we take a snapshot at a certain point in time, and that's a photograph. You have a picture, a still image, and that thing there in front of your eyes has shape, period. And if it has shape, it qualifies as an object. Very simple stuff, really baby stuff. Okay, there shouldn't be any argument about these things. Okay, one person who also believed, because of faulty definitions, right, was who believed that water and air and all that kind of fluids are not objects, was Ayn Rand. And people sometimes say, Bill, you said the same thing as Ayn Rand. I call it ain't for Ain't Rand, because she didn't have it right. She never got it right. She didn't know what an object was, what she called an entity. She did not know what exist means. So she failed the two key words of physics. And people say, well, she wasn't a physicist, she was a philosopher. No, she was not even a philosopher. A philosopher is someone who explains behavior, right? Reasons and purposes. And when Ayn Rand was a religious fanatic, she did politics. And politicians, people who do politics, are religious fanatics. Okay, that's what it is. It's opinion, it's recommendations how you should live. That's religion. That's got nothing to do with science. Okay, and you can see Ayn Rand just put everything related to perceptions and senses everywhere. You see the word perception everywhere there, and she says, an entity is a solid thing with a definite boundary, as against a fluid such as air. Air is not an entity. Fluids are not entities. And she said up at the top, an entity is a thing. Right, so she's saying that water is not a thing. She says air is not a thing. Fluids are not a thing. And that it just gives you an idea that she had no notion of what an object is, what a thing is. She had the same notion that everybody else had. Among them, these two gentlemen, they preceded her. Let's see. Give me a second here. I lost this file. These two gentlemen. There we go. Hume and Kant, okay, David Hume, and he says, he already said this in the 18th century, both of them really, said the idea of existence is the very same with the idea of perception or object, okay, so he's saying existence is object, things are existence, are existing. In other words, he saw no difference between the word exist and object. And at the bottom, he says the idea, when conjoined with the idea of an object, makes no addition to it. Whatever we conceive to be existent. Absolutely not. And Immanuel Kant, who came a little later, said more or less the same thing. By whatever and however many predicates I may think a thing is, nothing is really added to it if I add that the thing exists. And they were both obviously completely wrong. Yeah, and part of it is that they confused, like Ayn Rand here. Let me put her back. See at the bottom, she believed that exist and entity are the same, are synonyms, that they are the same things. Something exists which one perceives, and that's what she called an entity, something that perceive, whatever you perceive. So they don't see a difference between existence and perception, and between existence and an object, because they define both of them in the same way. And so we need to clarify that difference. No, exist is not the same thing as object. These are two different words. They mean something totally different. Exist means object that has location, and object is simply that which has shape. So in order for the object to exist, it must, in addition, which human couldn't figure out, neither could Ayn Rand. None of them could figure out that the difference is location. You need to have location. Here's a good old God. Okay, I hope all of you met him. That's God there. And that's an object. That's a thing. That's the only thing in the universe at that moment in time. You don't see anything else there. Okay, so God is flying around. He's the only object. And you can see he's not flying around really, because we took a snapshot of him. And so we can point to this thing, call it God. And so now you know what God is. And does God exist? Well, God doesn't exist yet, because God does not have location. In order for God to exist, this is what he's got to have. He's got to have distance with respect to every atom in the universe. Only then does God exist by definition, not because we believe or stop believing or don't know if to believe or not, or whatever answer people give related to belief and knowledge. No, God exists if God has location, and they have all the atoms in the universe. There's distance with respect to God from every atom in the universe. Now God exists. Okay, by definition, because that is the definition of exist, the scientific definition, the one we use in physics. Okay, so if God wants to exist, very easy. Just have location, and you can say, let us assume God exists. What did you say? Well, you said, let us assume God is an object first. Can't be a concept like love or intelligence. And God has distance with respect to everything that exists, everything that has location, every atom in the universe. Then God exists, by definition. So that's what you said when you say, let us assume God exists. Okay, so we have the foundations, and the first one is there, an object, that which has shape, right? And what do we propose here? Well, we propose something different than the establishment, because we do propose objects versus concepts. And one of the biggest concepts that got us in trouble really was this little concept here known as the electromagnetic wave. And this was started really, took its form, right? The concept, right, took its form in the 19th century. We have two gentlemen there. One is Fresnel and the other one is Maxwell. And they came up with this thingy. But what you're staring at is not a thingy, because what you're staring at is a bunch of arrows, and those arrows are vectors. What is a vector? Magnitude and direction. It's a mathematical concept. So they're building this thingy with mathematical concepts, and obviously a wave, an electromagnetic wave, a transverse wave is not a thing. You cannot say that's the mediator of light. Not in science. You can do that in religion, but not in science. So they failed there. They described this thing. They said, look, it's a mathematical description. Yeah, but you can't use that as a thing. And you see all these people illustrating and sometimes putting it in motion where the electromagnetic wave travels. It's very scary stuff, because they have a concept that is traveling. You have a bunch of vectors there, magnitude and direction, they're just numbers, and they're moving. All these numbers are moving, only after the 10th beer, And so what do? Well, we replace it with this. We replace it with the electromagnetic rope. We're saying that this is what they've been staring at without seeing for 200 years now. Okay, so we're saying we're replacing the electromagnetic wave with the electromagnetic rope. You can see why they got confused. They thought this thing vibrated, you know, and they said, you know, we don't understand what's there, but we can describe it with all these vectors. Yeah, all they had to do was replace it with a physical entity like we're doing there, putting a physical object, okay? And so here's our model for that. You have two atoms bound by that electromagnetic rope. They expand and contract doing their quantum jump, and by doing so, they torque the rope. And here it is. Okay, this is more or less what we're proposing. Everybody should be able to understand it just by looking, but we're giving you the explanation in the background. We're saying, look, the atom expands and contracts. By doing so, it torques the rope. Torsion is the fastest thing imaginable. That explains why light is so fast. Okay, so I think we're okay in everything. And another feature you can see there is amplitude. The rope has amplitude as well. So you have all the features. And here you have the model in static mode so that you can compare. You have the quantum model up at the top, and you can see what it is. You have this back and forth motion of the electron bead. For reasons that nobody knows, it jumps back and forth, right, between energy levels, which is a concept. Okay, so is the electron, by the way. The electron bead doesn't have any structure. Okay, or at least no known structure, right? They only talk about its mass and its charge. And why does it fall? Why does it rise? I mean, the question, the why question here is what compels it? What causes it to fall and rise? See, in our case, we have the shell, and it expands and contracts. So we can see why it occupies different, you can call it energy levels. But in their case, you know, why does the electron bead fall? What attracts it? What's in contact with the bead? That's the question. Okay? And then you have this electromagnetic wave that comes out of the atom and goes one way off to nowhere. Okay? So all these waves, they just fly out and nobody cares where they go. And we don't have that. We have a rope. It's connecting any two atoms. When it expands and contracts, it triggers the other atom to react. Okay, so when you have an atom from the sun that's got high frequency, it touches an atom here on Earth, and then because of the high frequency, it stimulates it and forces it to go faster or pump faster. Okay, so that's when you get a suntan. At the bottom, we see something that you know, the rope already explains right off the bat. The speed of light, why it's constant. Yes, under the rope model, it's a constant. Why? Because you have a rope there and a certain length of rope, and you can torque it as much as you want. Doesn't matter. All you are going to get is the link lengths are going to be shorter, and you're going to have more links, which is, you know, more links means frequency. Link length is the famous wavelength. So we can explain many features of our world with this model, okay, that quantum cannot explain whatsoever. Here's the construction. Okay, you can see it there. The thread turns, you know, the construction of the atom, right? You have the electric thread, the magnetic thread. We just use those words simply because of convention, to keep with convention. We have the blue one there going through the center of the atom and builds the proton star. Okay, and the magnetic thread, arbitrarily again, no difference in color or anything. It goes around and encapsulates the proton star. And so there's our atom. You can see all the other ropes converging upon our atom from every atom in the universe. So that's the construction. The construction is made of the same threads that build the rope that interconnects any two atoms. So it's not like the rope is connected or attached in some way. It's part of the atom in the sense that it turns into the atom. Each thread builds the atom as well and continues on the other side to other atoms. Okay, so it's that's our model, and for light, and then obviously we have very briefly here we have it for gravity as well. Okay, so I can put it up here. If every atom in an astronaut is connected to every atom on Earth, you can see why the astronaut falls to Earth. Okay, so there you have it. That's acceleration of gravity. It accelerates because the ropes fan out. And so we have an answer for the toe, the theory of everything. If you care to look at it as the gut, It's a little more than the gut, but the grand unified theory, we're uniting gravity with electromagnetism. And so, yeah, it's not an equation that's going to unite. It's going to be physics that's going to unite. And for physics, you need an object. The object is the rope. And the rope serves both for light as it does as well for gravity. And so here, once again, we have those are the foundations. You need the golden principle, which is you can't do physics without an object. An object is that which has shape. And so today, now that we have that introduction, that lengthy introduction, we're going to move to this, to the distance and location. You know, those are two words also misconceived, misdefined throughout history. And today we're going to try to define them properly, because those words are necessary to do physics. Not only do you need objects, but you need to define terms like, you know, what is distance? What is location? Right? What is space? You know, space is nothing, right? Synonym of nothing. And distance has something to do with space. It's that vacuum that's between any two objects.